So let A be a randomly chosen 5-element subset of S, which is all of the positive integers from 1 to 10 inclusive. Let D be the positive difference between the largest and smallest elements of A. Compute the expected value of D. So the first thing we notice is that there are 10 elements in S. So the number of different sets A that we can have is then equal to 10 choose 5, which evaluates out to 10 times 9 times 8 times 7 times 6 over 5 factorial, which is 252. So that's the total number of sets. Now, we want to compute the expected positive difference between the largest and smallest elements of A. Well, what are the possible values for D, this difference? Well, let's say that we have the set 1, 2, 3, 4, 5, right? And if we have that set, then that gives us D equals 4. Now, okay, that's a minimum value for D, but what the maximum value for D would be, say, if I have 1, and then I have some 3 numbers in the middle, and 10 at the end, and that gives me D equals 9. So to find the sum of all values of D over all 252 sets A, then we can compute the summation from D equals 4 to 9 of some expression. Now, what is this expression we want to compute? Well, first, for each of them, we want to find D, right? But then we want to multiply it by the number of sets that can have that value of D. Now, how do we find that? Well, we see that first, if we have D as the difference, how many values can we choose for the smallest element, right? So let's just take a look at these two cases on the left, for instance. So if D equals 9, that means there's only one choice, right? The smallest number has to be 1, because if the smallest number is 2, then D can be at most 8, which is a contradiction. Now, if D is equal to 4, that means starting from 1, 2, 3, 4, 5, right? If D is equal to 4, we're choosing any 5 consecutive integers in the set S, which means that this can go all the way up to the set 6, 7, 8, 9, 10, which means that from 1 to 6 as our lowest number, that gives us 6 choices for this smallest number. Let's call it I. So that means that for each value of D, there are 10 minus D ways to choose the smallest number. Then, how many ways are there to choose all the numbers in between, right? We saw that for D equals 4, we have to choose 3 numbers out of the 3 numbers in between. So that's only one way. But how can we generalize that? Well, we see that for D equals 9, there are 8 numbers between 1 and 10, and we have to choose 3 of them. Now, we're choosing 3 out of how many? Well, out of D minus 1, because when D is 9, there are 8 values. When D is 8, there's 7 values between the min and the max, and so on and so forth until we get down to when D equals 4, there's D minus 1 equals 3 values. So it's times D minus 1, choose 3. Now, after that, we can compute this summation, and doing that gives us 4 times 6 times 3 choose 3 plus 5 squared times 4 choose 3 plus 6 times 4, and then 3, 4, 5 choose 3. And then if we keep adding up by just continuing to substitute values of D in, we will eventually get this entire expression. 7 choose 3, and then our last term is just 9 times 8 choose 3. And if we evaluate this out, that gives us a total of 1,848. So the sum of all values of D over these 252 sets is 1,848. Over the 252 sets, that means that our expected value is 1,848 over 252, which expressed as a common fraction gives us 22 over 3. And that is our answer for target 4.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.